Hi, my name is Chantel, and I want to welcome you to my math channel. I want to do a lesson on parallel lines cut by transversal. So I just want you to see my face because I know I posted some videos earlier with just me actually doing the actual problem. But how my channel works, if you send me an email or a text message if you have my phone number, or just under this link if you give me a problem that you need help with by taking a picture of it and somehow making sure I get it, I'll do the problem and I'll post a video online for you to review. All right, so we're going to start with this lesson. I'm just going to start off with parallel lines, like I said, cut by transversal. So you're going to see me for a second, turn the camera around to get it right on the paper. I am going to get better at this, but I have to adjust this first. Let's see if I got it right. Sometimes, let's see if I got it. Just want to get it so I can write well. Let me see. And if you can see it well. Okay, I think I got it. All right, so yeah, we got it. Okay, so like I said, the lesson today is parallel lines cut by transversals. And the first thing I'm going to do is that I'm going to draw two parallel lines, okay? So I'm going to draw this line. I'm using line paper because it makes it easier for me to keep my line straight. And we know that parallel lines are lines that never touch or cross each other, and that they are side by side. So we're going to call this first one line A, and this one is line B. So we agree that both lines A and B are parallel. I'm also going to draw this little triangle here. You'll notice that in some textbooks or online, they'll draw this to represent that the lines are parallel, okay? All right, so lines A and B are parallel. They have the same slope. In this case, the slope is 0. We'll talk about slope in another lesson. And they never cross each other, and they're side by side. We're going to cut this line with a transversal. So I'm going to get another color, and I'm going to draw a line that's going to go, oops, pretend it is straight. I tried to be as straight as I could. All right, there we go. So this is a transversal. All right, so a transversal is a line that intersects two lines in the same plane at two different points. So it intersects at this point right here, and it intersects at that point. That's our transversal. When a transversal intersects two parallel lines, 8 angles are formed. Okay, so I'm going to show you these angles. Okay, so this one right here, this is the first angle. I'm going to call this angle number 1. We can label it whatever we want. Next to it, this is angle 2. This is angle 3. Angle 4. Down here is 5. Angle 6. Angle 7. And angle 8. I'm sure you noticed some things, like you may have noticed some obtuse angles and acute angles, vertical angles. So that's what we're going to talk about first. You may have noticed some complementary and supplementary angles. So before we get into the reasoning behind even learning about this, we're going to look at different angle types. Okay. All right. So let me see. I got it right here. Okay. So now the next type of angle we're going to talk about is, first let me label this T for transversal. So you know this is a transversal. All right, is a complementary angle, okay? And I'm going to actually write the word complementary, complementary angles. Okay, so think about it. If you know what a complementary angle is, basically, there are two angles whose measure adds up to 90 degrees, okay? So two angles whose measure add up to 90 degrees. Can you see that? I think you can see it. Okay. Uh-oh. There we go. I had to move some stuff over. I'm going to move my keyboard. I don't need that right now, so I'll move that over. So two angles whose measure add up to 90 degrees. Okay, so I'm going to draw a right angle. I'm going to freehand it. So we're going to use our imagination in case I'm off with it. All right, and I'm going to indicate a right angle. It's always indicate with this little square right here. So we know that a right angle equals 90 degrees. All right, everybody knows that right angle equals 90 degrees, and this is what the angle look like. We're going to label this angle. Okay, we're going to label this angle. This part of the line will be A. This part where this line and this line intersects will be B, and this part of this line will be C. So line A and line C, and where they intersect is at B. Okay, but this is angle ABC. All right. Okay. So I am going to, let me get another, I'm gonna almost like cut this angle, not in half, because you can see it's not even. Hopefully you can see that. I'm gonna cut this angle, and I'm gonna tell you that this angle right here, this one right here, is 50 degrees. Now, if this entire angle ABC is 50 degrees, right? And let me go ahead and put this and label this right here, this line dot intersected it with, we're going to call this line D. If this angle ABC equals 90 degrees, because it's a right angle, and angle DBC equals 50 degrees, can't we figure out the measure of angle ABD, this angle right here? Do you think it's going to be easy to figure out the measure of this angle? All right, let's think about it. So we know the measure of angle ABC, which is this angle right here, is equal to 90 degrees. And we know that the measure, I'm putting in for measure, of angle DBC, that's this angle right here, equals 50 degrees. We can find out the measure of angle ABD. Measure of angle ABD. And how do you suppose we do that? And most of you are probably saying it out loud to me. You're telling me, in order to find out the measure of this angle, all we need to do is subtract the total angle measure, which is 90 degrees, minus the measure of this angle, DBC, which is 50 degrees, right? And it gives us a measure of 40 degrees. So we're able to figure out that measure of angle ABD, that is 40 degrees, because of the concept of complementary angles. The complementary angles are two angles whose measures add up to 90 degrees. So if you're looking at a 90-degree angle, which is always indicated with this symbol right here, and they intersect it with a line like this one is, and they give you the measurement of one of the angles, you can always find the other angle by subtracting the 90-degree angle from whatever angle measurement they give you. Okay, so we're going to use the same concept, but now we're going to talk about supplementary angles. Okay, so let me see. I'm gonna use the brown color. All right, so complementary angles are two angles whose measure equal 90 degrees. Let's talk about supplementary angles. All right, so if I was going to double the amount, right, or if I'm talking about a straight line, if I doubled the 90, we would get 180 degrees. So knowing that, would you guess that supplementary angles are two angles whose measure add up to 180 degrees, okay? And 180 degrees, as you guys may know, I'm gonna pull this up a little bit, is a straight line. I guess I should have gotten my my protractor, but that's okay. I'm assuming you guys are gonna believe me, okay? All right, so this is a straight line. Okay, now, just because I'm going to divide this straight line into sections, I'm going to label portions of it, all right? So I'm going to divide this line into 3 sections, and I will change the color. All right, so this is point A on the line. This is point B on this line. And, uh-oh, I got low battery. Uh-oh, and this is point C on the line. Let me see if I can plug up my charger while I got this phone here so it doesn't die on us. Okay, I got it plugged up. We should be good. All right. All right. Okay. So this is a straight line, and I've indicated 3 different points on this line. Okay. So this entire line, and I do not have my protractor, but I could go get it if you don't mind waiting. No, you'll believe me. Okay. If I put my protractor right here, it would show you that the measurement from this side A all the way to this side C right here, right, is 180 degrees. Okay. So this whole line equals 180 degrees. So I can say the measure of angle ABC in this particular problem is 180 degrees, okay? I'm going to divide the line. You ready? All right, so I'm going to create an intersection, pretend that it's straight. I'm doing my best because I'm kind of working sideways here, okay? And I'm going to say that this angle that I created off of point B is 80 degrees, okay? So the measurement, I'm also going to call this right here, look what I'm going to do. I'm going to call this, I'm going to give it a point on here so we can easily label our angle. So now I'm going to say the measurement of angle A, B, D equals 80 degrees. Does everybody agree? So the measurement of this angle right here is 80 degrees. Now we know this whole angle equals 180 degrees. How do you suppose we figure out the measurement of angle DBC? How do we find this measurement? So hopefully most of you are screaming out, oh, we're going to subtract 180 from 80, from this degree, from this angle measurement right here, and we're going to get 100 degrees. So the measurement of angle DBC is going to be 100 degrees. Okay, and we're able to do that because we know that a straight angle equals 180 degrees. Let me see if I can put this here. Straight angle equals 180 degrees. Okay, all right. So since we're like looking at this little section right here, and we see we got this angle right here that's 80 degrees, and this angle right here that's 100, we might as well talk about what adjacent angles are. Okay, so adjacent angles are angles that are side by side or next to each other. Okay, so this angle right here and this angle right here are adjacent angles. ADJACENT, adjacent angles. And they are angles that are side by side angles, or next to each other. All right, okay. Now, that's part one of our vocabulary. I'm going to stop it here to see how the video is looking, and then I'm going to give you a few more vocabulary terms and examples, and then we're going to actually do some problems involving parallel lines cut by transversals. Okay, I hope this video helps.